So we're taking a break off from working in the shop to do a project that I've had sitting around for a little while. It's a beautiful 75-degree unseasonably warm day here in Georgia for January. Unseasonably warm for January. And we're going to be installing a ambient weather WS 1400 IP observer internet weather station. Well, what does all that mean? This will measure temperature, humidity, wind speed, wind direction, rainfall, solar radiation, and UV. Basically, it pulls in all the weather information you could ever want. I think the UV and the solar radiation are a part of the fact that the thing is solar powered. It has rechargeable batteries, so you can mount it somewhere. You don't have to worry about it. It wirelessly transmits back to a base station. Got everything here in the box. So try not to break things. So you've got the main unit here just for scale. You've got your rain collection here, wind direction, wind speed, and then it's got the solar panel. And then it transmits to a little base station that is connected to your wired internet connection. So it's got a LAN connection there on the back. So it's wireless from here to here. Also, it pulls from another sensor where you have temperature, pressure, and humidity for your inside. The reason I'm doing this is to give me an extra level of things that I'm able to do with my home automation system. So I really don't need the inside temperature and humidity. I already have that through my thermostats that are also controlled by the automation system. They're all Z-Wave. But the main thing I'm going for is to be able to use outside information to control both my heating and air conditioning system and how that operates, and my irrigation system to help conserve water there. I've got a heat pump system, so you can gain a lot of efficiency from the way you run it based on outside temperatures and how you operate that. Also, we have a whole house fan currently that I have set up on the automation system for it to turn on and off, and it's just based on general weather for outside. This will give me a more accurate reading for that. It'll also allow me to do some extra controls based on what the humidity is outside, because if it's really humid outdoors, you don't want to suck all that air inside all the time, depending on what your target is. So that's where it would be nice to also, I can compare those to the inside humidity numbers. So let me take a second and I'll just do a little drawing here of basically what we're trying to achieve with the home automation system in terms of controlling the heat pump. Okay, so here's my crude rendering of what we're trying to achieve by combining this system with the home automation control of my two heat pumps. So this is sort of, I guess this is temperature across here, time. So we've got midnight, noon, and in a typical day, unless there's a front coming through, you'll see where the temperature, well, it wouldn't actually go like this, but you'll see the temperature kind of hit its low at, right before the sun comes up, and then it'll gradually build through the day to a high point that, usually here is, 2, 3 o'clock in the time of year where I care about this. So the idea is the heat pump functions a lot more efficiently the closer, the warmer it is outside, basically. And the colder it gets, the more inefficiently it operates. So as we get to this warmer point, we're watching the inside temperature and say, during this time, we want it to be 68 degrees, whatever, inside. My system also knows whether I'm home or whether someone else is here based on different factors. But so if the house is occupied, whatever, 68 is fine. If nobody's here, then I may have it drop just a little bit lower to the point where basically we don't want it to run very much during this initial phase. And then once we get to where we start increasing, kind of depending on, well, it's probably be an algorithm I'm going to have to play with, but basically during this peak time, we want to get the temperature up to, say, maybe as high as 76 degrees, something like that, inside the house. But at the same time, we don't want to just basically jump up to that point, because then we're gonna run it. If we run it constantly, then it'll still kick on to the backup electric heat, which is the pure electric heat, non-heat pump, in order to warm up the heat pump, which basically uses a lot more electricity. So we're trying to let it run for a little bit, let it stop, and basically kind of walk it up from whatever this lower temperature we're set at to get to this peak temperature. So our target normally would be, we know, okay, the outside temperature, we know what the high is based on weather prediction, for the day, and then we know fairly exactly what the outside temperature is based on what the weather station is sending us. So we get to this point, we turn on, we let it run, maybe run up a degree, and then we have a timer in there that counts to say, hey, well, we've let it set for 10 minutes, because it also knows when the thermostat's actually kicked on and when the unit is actually running. So we wait till the unit shuts off, which means it's reached that degree higher, and then we let it sit for, say, 10 minutes to let the coil on the outside acclimate back to the outside temperature. And then we walk it up another degree. I may have to play with it in terms of it saying, hey, well, it's this, we've only reached a certain point and we need to get to so far before it starts to cool off again. Maybe we take bigger steps, or there's adjustments that can be made in there once this is put into play. This is just the basic theory of what we're trying to do. The other thing is, on older units, I think some newer units will have an outside temperature sensor where they actually won't try to run the heat pump when you get below. Well, actually, newer units are more efficient, so they aren't as concerned about running in lower temperatures. But from what I've been told, around 45 degrees, 40 degrees is in that window where you're better off from an efficiency standpoint to just run the electric heat, the grid heat, within the system. Sometimes it's marked as auxiliary or emergency heat, and use that without the unit trying to run the compressor, because basically you're wasting the electricity of running the compressor. When it's colder outside, then the compressor is really going to be able to efficiently pull heat from the outdoors and put it into the house. So the idea being, when the outside temperature, when we know that it's dropped below, say, 45 degrees, I can have the automation system change all the thermostats directly to that auxiliary or emergency heat setting, where they don't even try to turn on the heat pump. And then once we get back to that point the next morning, as it starts to warm up, then okay, we'll go ahead and we'll switch it back to where the heat pump can run, just in the case that it's trying to still call for heat, like say that it's still trying to get to 68 degrees. Because the idea here is that we would get the house in this situation where it's going to drop below that point. We would probably let it run, if it can maintain this higher temperature in the 75, 76 degrees, get it to the point where we're right about there, and then let it kind of cruise through the evening. You just basically rely on the thermal mass of the house that you've already built up, and just kind of let yourself glide through the evening, and hope that you're kind of still in that 68 range for the next day, without having to put a whole lot of energy in here at nighttime, where it's going to be the most expensive, because we've switched to the grid heat. So that's the highest electrical use. So basically we can get back to that point, and then the next day it's going to get warm enough that we wait until, in this drawing I kind of made it so that we could tell, hey, well, a front came through, let's say earlier in the day, and for some reason it was warmer before noon in this kind of drawing here. We would still know that, hey, we're at this point in the peak, let's go ahead and start raising that temperature. I don't know that I'll be able to account for the fact that it's cooling off later in the day, but basically we try to get to that 76 degrees, right after this point. We'd work our way up, work the way up in the house temperature during that period of time when it's the warmest outside, and we can use the heat pump most efficiently. Basically, that's the idea. I also have a whole house fan that essentially would work the opposite direction, where say it's going to be 80 degrees. We have a lot of time here in Georgia where it's in the spring and fall that it's 80, mid 80s during the day, and then we get down to the nighttime and it's 50s, 60s. Well, if the other factors, as far as humidity outside and things like that are in line, you can set it so that during that cool time, you've got the whole house fan running where it's pulling cool air into the house. You're not putting any energy into running the air conditioner. And then once you either get the house to the point where it's the same temperature as the outside, or it starts to warm up past what your target temperature is, then you turn off your whole house fan and try to cruise through the day and try to maintain that temperature. And I've done this manually for years. Obviously it's not as efficient as if I have a system controlling it all the time, but basically I can get it even if it's 80 degrees here. My house a lot of times will cruise to the point where at 7, 8 o'clock at night it's still only gotten up to 76 degrees, because I've run it down to 65 during the nighttime, and then let it kind of just cruise back up during the day. So there's a lot of efficiency you can gain from that. But again, the humidity is a factor, because if you're bringing in that cool air, and especially in the summer when there's a lot of humidity in the air, you get that, you build up a lot of humidity in the house, and then when you do have to switch over to the air conditioning, you got to try to run it longer to get all that out of there. But this is a really good system, and I've got some changes planned for how my home automation actually controls the whole house fan and how that works. Basically, the kink in the system is that I have to be there to open the windows, and with the system that I'm looking at, I'll be able to run it without having to open the windows. That'll happen automatically, not by opening the windows, but by another system. Also, we have pollen issues here in the spring, and the idea is that we'll have a filter set up that'll prevent that from being an issue. So that's the basics of what we're trying to achieve here, and now we're gonna move on to the install. I'll probably just pick it up after I get this thing mounted and kind of installed. So obviously we're on the roof now. We've got everything mounted, and this isn't the ideal situation for mounting this. They really want you to have it on a pole kind of out in the middle of nowhere. Unfortunately, I'm surrounded by 60-foot trees here and don't have a lot of open area. So I went ahead and just mounted it here on the roof. I used a piece of, it's a top rail for a chain link fence, was the right size pipe to match up with the mount that it comes with. So I used that and kind of changed around the brackets that it came with and got that mounted. I do have it, it's probably 10 feet up from the roof surface. It's really not probably the ideal thing for temperature in the summer when you've got a lot of heat coming off the roof. We are kind of in the middle of my roof, so I've got to think that that's going to affect the temperature. You can put in some correction factors in the software, but that wouldn't be the same all year round, so I don't know that that's going to be the solution to that either. I think my longer term solution is that when I build a new building to replace my current garage, I'll mount it some way on there. I just don't have an open spot that I can put this thing on a pole. I mean, the ideal thing is you put it on they've got a math equation for how far away you are from the tallest object, and how tall you're supposed to put it off the ground. But I could probably put it out in the middle of my garden, but it's just kind of an annoyance to have it in the middle there. So we'll see how this works with it on the roof. I think it's going to work well. My main concern is just temperature based on just the heat coming off the roof here. But main thing is you want to have it level so that your wind direction operates correctly, so the weather vane isn't tilted one way or another. So you need to get on a pole that's fairly straight up and down. There's a transmitter inside the house that I showed earlier that is connected now and is working. So I've got that all set up, and it is reporting data. I did get it set up with the Well, one of the main reasons to buy this specific unit is that it's set up to work directly with Weather Underground, which is what I use mainly for my weather forecast. So it'll basically report as a personal weather station on there. You can have your own web page. It does that. What your weather information does go out publicly, but it does give you a really good interface for showing how much rainfall you've had and temperature, history and that kind of thing. I'm waiting for, it seems like you have to wait for an update to come through for it to show the weather station code in both my home seer system and through the Android app. But once that comes through, then I'll be able to link directly to that weather station, have a forecast specific to right here. The other thing that I noticed is that it does have an illumination sensor. I talked about that earlier. I thought it was through the solar panel, but there is a separate sensor. So, like right now, it's starting to get dark, but say it was overcast, my sensors that are in the house, I have motion sensors in a lot of my rooms, but they're lower priced ones that don't also have an ambient light sensor in them. So with this system, should be able to have some idea of, hey, is it really cloudy out, and do I need to turn the lights on in this room? Because normally I have it set so that if there's motion after sunset, then the lights will come on. For rooms in the basement, that's a little bit different, but for the rooms where there's windows, you wait till there's the sunset, and then those lights will come on when somebody walks through the room. But with this, I should be able to tune it to, if it's the middle of the afternoon and for some reason it's pitch black outside, or it's fairly overcast where you would want a light on inside, then it should be able to make that adjustment beyond. So there's an extra level of stuff that you can do with this beyond what I talked about with the irrigation and heating and cooling. But overall, I think this is going to be a good product. Like I said, I haven't got all the software set up yet as far as the connection to the home automation, because I'm waiting for it to update through the Weather Underground system. But I do have it set up with Weather Underground, and I can use the web page, and it is reporting. So that's all working well, and so far it's been a great product. One quick little addendum to this I was noticing while I was editing I didn't mention is that when you sign up for the Weather Underground setup and include your own weather data, because you're sharing that with everyone else on there, they basically give you a premium membership that removes all the ads. So that's a nice plus to have, because if you've ever left that web page open, it just keeps reloading because it's reloading those ads, and they're trying to get more and more impressions, I think. So that's another big benefit of having this set up and using it when it's tied into Weather Underground. We're taking a break off from working in the shop to do a project that I've had sitting around for a little while. It's a beautiful 75-degree unseasonably warm day here in Georgia for January. Unseasonably warm for January. And we're going to be installing a ambient weather WS 1400 IP observer internet weather station. Well, what does all that mean? This will measure temperature, humidity, wind speed, wind direction, rainfall, solar radiation, and UV. Basically, it pulls in all the weather information you could ever want. I think the UV and the solar radiation are part of the fact that the thing is solar powered. It has rechargeable batteries, so you can mount it somewhere. You don't have to worry about it. It wirelessly transmits back to a base station. Got everything here in the box. So, trying to break things. So you've got the main unit here, just for scale. You've got your rain collection here, wind direction, wind speed, and then it's got the solar panel. And then it transmits to a little base station that is connected to your wired internet connection. So it's got a LAN connection there on the back. So it's wireless from here to here. Also, it pulls from another sensor where you have temperature, pressure, and humidity for your inside. The reason I'm doing this is to give me an extra level of things that I'm able to do with my home automation system. So I really don't need the inside temperature and humidity. I